Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator from the channel, and I hope you are all enjoying your studies and doing awesomely well. In this lecture today, we are going to learn how we are going to find the number of chiral carbons in a molecule. So let us begin the learning, first of all by understanding what is a chiral carbon. So a chiral carbon, this is also called as an asymmetric carbon. It is also called as a chirality center. It is also called as a stereo center. It is also called as a stereogenic center. But what is a chiral carbon? Well, a single sp3 tetrahedral carbon atom attached to four different groups is called as a chiral carbon. For example, if you look at this molecule, we have this black to be a carbon, and this carbon, this is surrounded by four different groups, a CH3, a C2H5, this is OH and H. What is the name of this molecule? Well, if you count the number of carbons, carbon number 1, carbon number 2, and we have two carbons over here, so 3 and 4. The word root is going to be but, right? We have all single covalent bonds over here, so it is going to be but-un, and we have a all over here, right? Because we have a OH as the functional group. So this is butanol, and we have the OH at position number 2. So this is butane 2 all or 2-butanol. Now this is a molecule of butane 2 all where we have one chiral carbon, which means that there is a carbon which is surrounded by four different groups, and the four different groups, they are forming single or sigma covalent bonds with this carbon, a single sp3 tetrahedral atom. The carbon, this is sp3 hybridized, all these four groups, they are going to be arranged tetrahedrally around this carbon. Such a carbon we call as a chiral carbon, right? Now this is also called as an asymmetric carbon because there is no symmetry around this carbon, because we have all four different groups attached to this carbon. It is also called as a chirality center because this is responsible for chirality in a molecule. Alright. Now one thing that you have to remember is that if in a molecule only one chirality center is present, well, this molecule is going to be 100% chiral. But in case we have more than one chirality center in the molecule, that molecule may or may not be chiral. Okay, this is something that I have done in detail a discussion in my detailed course on general organic chemistry. That is general organic chemistry part 2, where we are discussing each and everything about isomerism for organic compounds. There, the lectures on optical isomerism, you can watch lecture number 2 of optical isomerism, or so there you can have this all understanding in detail. Now we have a chiral carbon over here, and we can write this. This is a 3D diagram for it, but this is simply how you write the structure of butane 2 all. And here you have to first of all identify, because this is how you're going to write in the examination. You're not going to make this way. So you will be writing the structure like this, and then you will see which of the carbons is attached to four different groups. So it is this carbon over here which is attached to a CH3, a C2H5, a H and a OH, and will be a chiral carbon, right? And we denote a chiral carbon by writing an asterisk over it so that we can identify very easily. What about the rest of the carbons? Well, if you look at the CH3, so we have this carbon which is attached to three hydrogens. So all the groups, they are not going to be different. In fact, we have three groups which are going to be same around this carbon. So this will not be a chirality center. Similarly, we have a CH2, again two hydrogens common, and again a CH3, three hydrogens common for this carbon. So in this molecule, we have just one chirality center. This molecule is 100% going to be a chiral molecule. Now the asymmetric carbon, as I just now told you, this is indicated by an asterisk. the difference in the groups bonded to the asymmetric carbon is not necessarily right next to the asymmetric carbon. This is something that you have to remember. For example, let us see one more. We have this over here, a 4-octanol. In this, what you can see is that this is the carbon which we have marked by an asterisk. So if you look at this, we have to this carbon attached a H, a OH, a propyl group and a butyl group. So these are 4 different groups. Generally what the students, they confuse themselves is that the carbon, well, this one is the carbon. So this is attached to a hydrogen, this is attached to an oxygen atom, and this is attached to a carbon and to a carbon. Let me just elaborate it. This is a carbon, this is attached to a hydrogen, this is attached to a OH, okay, and on two sides it is attached to a carbon. One is the carbon which is for this propyl group and one is the carbon which is for this butyl group. Alright. So what the children think is that, well, this is also a carbon and this is also a carbon. So these are two similar groups around the carbon. Why are we calling it to be a chiral carbon? When the necessity condition is it should be 4 different groups. So we are not saying atoms, we are saying groups, and group around this carbon in the molecule is going to be a propyl and it is going to be a butyl. Alright. So therefore we have a propyl. If I just write a P over here and I write a butyl, a B over here, then you can see that there are 4 different groups surrounding the carbon and hence this carbon is going to be a chiral carbon. Alright. So what do you have to identify? You have to identify 4 different groups around a carbon and it has to be 4 sigma bonds that this carbon should be making. That is also very important that you remember, right? 4 sigma bonds, 4 different groups around the carbon. Let us see one more example. We have 2 bromobutane. In this, what you can see is this is the carbon. It is attached to a hydrogen, a bromine, a methyl group and a ethyl group. So all 4 different groups again. So this carbon is going to be a chiral carbon. And the next one, well, this one over here, well, we have this carbon to be a chiral carbon. It is attached to a hydrogen, a CH3, that is a methyl group, a C2H5, a CH2CH3, so this is ethyl group, and this one over here, this is the isobutyl group. So again, 4 different groups attached to the carbon. For all the rest of the carbons, you will be seeing that there are going to be similar groups around the carbon. For example, if you look at this one also, this carbon, it is attached to a hydrogen and this is attached to 2 CH3 groups. So again, we have a similar group over here around the carbon. So we will be having only one chiral carbon in the molecule. I hope this is clear. So now let us do some practice questions so that you become perfect in the concept. So these are the practice problems. I have 10 problems for you. 6 you can see over here and they're going to be 4 another. What I want you to do is, first of all, look at each of the carbons yourself and identify which of the carbons is going to be a chiral carbon. Alright. And then you have to write the total number of chiral carbons in the molecule. So this is what you have to do. These are first 6 and these are the next 4, making it a total of 10. So you can pause the lecture over here, try all these questions yourself and then look at the solutions. So let us quickly look at the answers to these questions one by one. The first question, a very simple one. We have just one carbon in the molecule which is surrounded by 4 different groups. So this carbon, which we have denoted by an asterisk, this is going to be a chiral carbon. One chiral carbon in the molecule. The next one, again, you can see that this carbon is attached to 4 different groups. So this is going to be one chiral carbon in the molecule. The other carbons, they are going to be attached to similar groups, the hydrogens. Therefore, they cannot be chiral. The third one, this is a long carbon chain and where you can see different groups attached. So the first carbon, this one, the start of the chain and the side, whichever you may say the start or the end, well, these two terminal carbons, they are CH3s. So again, these are going to be attached to similar groups. So these cannot be chiral, but for the rest of them, now just see over here, this carbon over here, right? So this carbon will be attached to a CH3, a chlorine, and a big carbon group for the first position, what you're seeing, a OH. So we have different groups of carbons attached to this carbon, and the fourth one is going to be a hydrogen, right? So here we will be having a fourth one to be hydrogen. So this carbon, well, this is going to be a chiral carbon. Similarly, the next one hydrogen, one OH. This carbon you can see is a chlorine attached. If you move on to this side, you will be seeing a carbon which is attached to a OH group and a long carbon chain as well. So again, we have different groups attached. Similarly, this one, and this one, all five of them, they are going to be chiral because they are going to be attached to different groups of atoms. Now, whether the molecules, they are themselves chiral or not, well, this depends upon the number of chirality centers, the symmetry in the molecule, the plane of symmetry, the center of symmetry, all that we have done a detailed discussion in the course on isomerism, that is GOC part 2 from us. So in case you want to have a detailed understanding of each and every concept, do follow that course. So now coming up to question number 4, and question number 4, you can see that we have a cyclic ring. Whenever you have a cyclic ring, just remember the carbons which are just are a part of the chain only, they are not attached to any substituent like this one. Okay, so here this carbon is attached to a CH3, but this carbon over here, this is not attached to anything except the carbons of the ring. What this means is that this is forming two bonds with hydrogen. Alright, and such carbons, because they are having two similar hydrogens, they cannot be chiral. So this one, first of all, you can just omit. You do not need to look at what are they going to form, whether chiral or not. This one is out of question. This one is out of question. Similarly, if you look at this carbon over here, well, this carbon is going to be sp2 hybridized because it is forming a double bond. Similarly, this one is also sp2 hybridized. And an essential condition for chirality center or a chiral carbon is that carbon atom should be sp3 hybridized. It should be forming 4 sigma bonds. It should not be forming a double bond or a triple bond. And because these carbons, they are forming a double bond, so these can also not be the chiral carbons, right? So 4, they are just gone out of question. The rest, what you have to see is the 2 which we can discuss now. Let me just clear this out. So the carbons which are left in question is going to be this carbon and this carbon. So how do you proceed for them? First of all, what you can see is that we have a CH3 and a hydrogen attached. So these two groups, they are different. Now what you have to see is the ring. You have to move either side of the ring, okay, this way and this way, and see if you find identical positions of the carbons or different. For example, when you move this side for this carbon atom, what you can see is that first of all you will be encountering a CH2, alright, and on this side you are encountering a CH3. So these are different. So therefore this carbon should be a chiral carbon, alright. So it is a chiral carbon. Similarly, the next one also, when you're going to move this side, you will be finding this side a carbon with a methyl group, and when you are going to move this side, you will be encountering a carbon which is forming a double bond. So we have 4 different groups attached to the carbon. So this is how you will be looking at the carbon atoms in the ring. Alright. Where you're not finding anything written, that is a CH2. So first of all, just remove those. And if there are double bonds being formed, you're not going to look at them as well. So you can say that we have 2 chiral carbons in this molecule. The next one, now in this one, what you can see is first of all, this carbon, this one and this one, they are out of question. Here we will be having 2 hydrogens. Left is this carbon and this carbon, right? So here at this carbon we have one CH3, one hydrogen, two different groups. What you have to see is now moving this side and this side. Do you encounter similar things? Well, if you move on to this side, you will be encountering a CH2, here also a CH2. Moving further, a CH2, a CH2, and moving further, from this side also you are encountering a carbon with a methyl group, this side also a carbon with a methyl group. So these are identical groups coming both ways. So therefore, this carbon is also going to be achiral and this one is also going to be achiral. There is going to be no chirality center in this molecule, right? I hope this is clear how you are ascertaining the number of chiral atoms. Let us look at one more. So here again you can see a cyclic ring and here we have an OH group at all the three carbons. So this means that we are just not simply going to outrule, fine, because we have no carbon where there is a CH2 and we can omit that. But we have different groups over here, a OH, a OH, a OH. So how do we see over here? Again, what you have to check is that at all of the positions you will be having a H and a OH, a H and a OH, a H and a OH, right? So two groups, you know they are different. The rest you have to move again. For example, when you move from this carbon this way and this way, you are encountering a carbon with a OH, a carbon with a OH. So this is going to be same movement for all of them. If you move for this carbon, you will be encountering a OH, a OH. So again similar. For this one also, you are going to move this way and you're going to move this way. You will be finding identical carbon atoms. So they are going to be similar groups for all the three carbons. I hope this is clear how you are going to see. You are just going to move left and right of the carbon to find whether you are encountering similar groups or different groups. So in this molecule also you will be finding zero chiral carbon. So now coming up to question number 7, and question number 7, what you can see is that one of the rings has a double bond. So a double bond means that this carbon is going to be sp2 hybridized. This one is also sp2 hybridized, right? This one is a CH2, 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 this one is also a CH2. So these cannot be chiral carbons. Remaining is this carbon over here which is forming 3 bonds, and the fourth one is going to be a hydrogen, and this one which is forming 3 bonds, and the fourth one is going to be hydrogen. So here what you can see is for this carbon, well, if you move this side, you will be encountering first of all single bonds. When you move this side, you will be encountering a double bond. So this is going to be different on both sides and hence 4 different groups. Similarly, this one is also going to have 4 different groups. So what do we get? Well, for this structure, what we will be having is 2 chiral carbons. Let me just show you with the asterisks also the carbons. So these are the 2 carbons which are chiral. Alright, I hope this is clear. Let us look at the next one. So in this one, again what you will be finding is when you are going to check the atoms where you are forming 3 bonds. The 2 bonds, you have to just outrule them, that is out of question. Wherever you are just forming 3 bonds, what you will be finding is that they are going to be all similar and therefore it is going to be 0 chiral carbon for this molecule. If I just show you the example of one, well, this one over here. Okay, so this carbon, when you are going to move either side, when you are moving this side, you are finding the same structure. When you are moving this side, you are finding the same structure. When you are moving down, you will be encountering the same. When you are moving this way, you will be encountering the same type of atoms. So these are going to be achiral. Alright, so these cannot be acting as chirality centers. The next one, this one over here, again you are going to outrule first of all those carbons which are just forming 2 bonds. Which are the carbons which are forming 3 bonds? Let us see. First of all, this one, this one, this one is forming 3 bonds and this is forming 3 bonds. Right? So these are the 4 atoms which are forming 3 bonds which can be possibly chiral centers. Now you are going to again check this one. For this one and this one, you are going to encounter similar groups. But for this carbon and this carbon, you will be encountering different groups. For example, when, just let me clear this, then you will be able to see it. So when you will be for this carbon, when you move this side and you move this side, you do not see identical structures, right? So therefore, this carbon as well as this carbon, these are going to be the chirality centers in this molecule. Alright, so I hope now you are getting everything. So these two, they are going to be the chiral carbons. Easy enough, and you now know how you are going to quickly see them also. So now the last one, and here we have a big structure. So here what are you going to do for the straight chains? You are going to see the carbons which are forming just one bond or two bonds. Well, those will be having similar hydrogens, so they cannot be chirality centers. And for the ring where there are going to be two bonds that you can see in the structure, well, they are not going to be chirality centers. And for the rest, you will have to check one by one that whether they are having different groups or not. And in this, I have just labeled the chiral centers, and these are 9 of them. So please do ascertain them yourself whether you were able to find all these 9 or not, right? So that would be all for this lecture. I hope you all have understood how we are going to find out the number of chiral carbons in a molecule. And if any now is given to you, you are certainly going to find the correct number. In case you want to have a detailed understanding of all the concepts of optical isomerism, please do join us at H2O Chemistry. We are putting up a detailed course on isomerism, which is in GOC Part 2. Alright, so GOC Part 1 was a detailed discussion on the nomenclature of organic compounds, and GOC Part 2, we are discussing each and every concept of isomerism in detail. And then we will be moving on to GOC Part 3, where we are going to discuss all the mechanism of reactions for organic chemistry in detail. So for all detailed understanding of each and every concept in chemistry for the best possible preparation for JEE and NEET, please do join us at H2O Chemistry. So see you again. Have a nice day. God bless you.